Welcome back everyone, Patrick here, moving on to another word problem dealing with quadratics. So we're told a parabolic tunnel is 10 meters high and 30 meters wide at the base. So part A, we have to find two equations. We have to find an equation modeling the height if either you place the vertex on the y-axis or you place one end of the base at the origin. So two different scenarios, two different equations there. And then in part B, how high is the bridge at a horizontal distance of 3 meters from one end? And we have to confirm that with both equations in part A. So we've done questions like this before where we are dealing with a tunnel. Sometimes it's a bridge as well. And there's usually two ways that these kinds of scenarios are modeled. So either this parabolic tunnel, the vertex of it is on the y-axis, or in this case it's going to end up being the h-axis, right? Because we're going to be dealing with height. And then we have an x value here. I'm going to discuss what x means in a sec. So this is one way to model it, right? This is the ground. Over here, the road, and then this is the tunnel. And then the other way to model a scenario like this, actually we don't need all that, is if we place one end of the tunnel at the origin. And so it ends up being like that. Technically, you can also make the tunnel like this on this side, but then you're going to be dealing with negative x values, and then it gets a little bit weird. But you can technically do that. But I'm going to put the end at the origin over here. And so we're still dealing with height, and then we're going to have an x value over here. Now the x variable in both of these scenarios, it represents something different. The height is the same, but the x over here, it represents the horizontal distance from the center of the tunnel. Okay, you can see that in the diagram. So like an x value of 1, for example, would represent 1 meter away from the center of the tunnel. This is the center, right? The axis of symmetry. So the 1 represents 1 meter away from the center of the tunnel, a horizontal distance of 1 meter away. And then that's at that horizontal distance, we're going to get a certain height up there. So that's what x represents in this scenario. Over here, what the x represents is something different. Here, x represents the horizontal distance from one end of the tunnel, right? So like an x value of 1 would represent a horizontal distance of 1 meter from the end of the tunnel. Okay, and then at that horizontal distance, you'd have a certain height up there. So it's really important what the x value represents, especially when we're going to be doing part B. Okay, now for both of these, it's going to be the same scenario. Okay, so starting with this one, a parabolic tunnel is 10 meters high, which means that we know that the max height is going to be 10. And notice what's the x value of the vertex in this case, because it's on that h-axis, the x value is going to be 0, the h value of the vertex is going to be 10. Okay, and then we're told it's also 30 meters wide, meaning the distance from here to here is 30. Well, if it gets cut in half right at 0, then what's this distance over here? Well, we know it's going to be 15, right? Half of 30, so we know this point is going to be negative 15 and 0. This point here, because this distance is also 15, this point is going to be 15 and 0 like that, right? And then we're dealing with the x value still there. Versus over here, we're dealing with the origin. We know this is going to be 0 and 0. Because this is 30, right? It's the same tunnel. We know this is going to be 30 and 0 like that, right? So we're dealing with different intercepts. Now the height of the tunnel is the same, so we know that the h value of this vertex is still going to be 10, what's the x value of that vertex going to be? Well, remember the vertex, or the x value of a vertex, the axis of symmetry is always the midpoint between the intercepts. So notice the midpoint between -15 and +15 is what? 0. So that's how we got that x value 0. Well, what's the midpoint between 0 and 30? We're dealing with different intercepts here. It's going to be 15. So we know that this x value here is going to be 15. So the vertex in this case is 15 and 10. And so we have enough information for both of these now to create equations for them. Now there's multiple ways to create the equations because we have the intercepts and we also have the vertex. We could use factored form or vertex form. I'm going to start off, maybe I'll do both, but I'll do the factored form first, because this section is basically graphing using the intercepts. So with an x-intercept of -15, what's the factor going to be? It's going to be x plus 15, right? What's the factor going to be for an x-intercept of +15? It's going to be x minus 15. And then we still have to solve for this a value, and we can use that, or we can use the vertex to solve for that a value. So we'd plug in 10 for h, and then we plug in 0 for the x values. Okay, so we'd end up with 15, +15 times -15, which would give us -225. Then we still have the a value. This would be 10. Divide both sides by -225. And we'd end up with what? A equaling -10 over 225. If we divide this by 5, we'd end up with -2. If we divide this by 5, we'd end up with what? 45? So -2 over 45 ends up being the a value in this case. It makes sense that it's negative because we're dealing with a parabola that's opening down. So that a value would go here. So we'll have h equals -2 over 45, like that. Okay, so this here represents the factored form for this parabola. And then if you want to get the vertex form, or let's start off with the standard form actually. So if we expand everything, this is a difference of squares. That would just be x squared minus 225. And we'd end up distributing the -2 over 45. So we'd end up with -2 over 45 x squared. And then -2 over 45 times this -225 would be what? This would be 5, so +10, like that. And that actually makes sense because remember, for a parabola, that's y equals ax squared plus c, the vertex is always going to be at 0 and c, right? So it's going to be at 0 and 10. So it makes sense that we got a value of 10 right there, right? Because that's going to be the vertex. Okay, so you could also get the standard form, and then if you wanted to get the vertex form, actually in this case, the standard form and the vertex form are the same, right? Going back to that just original general parabola where you don't have that bx term. This is the same as like ax minus 0 squared plus k, right? Where the k and the c are going to be the same in this case. So the standard form and the vertex form are the same, but if you wanted to get the equation using the vertex form, it would be ax minus 0 squared plus 10, right? Because the vertex is 0 and 10. Then you could plug in either 15 and 0 or -15 and 0 for the x and h to solve for the a value. So if we use 15 and 0, we plug in 0 for h, a 15 minus 0 squared plus 10, bring the 10 over, we'll have -10 equals 15 squared is 225, 225a. So the a would end up being -2 over 45 again. And so plugging in that a value over here, right, x minus 0 is just x squared, so that'll just be x squared plus 10. right? So we end up with that same format. The standard form, the vertex form, is the same. It's not going to be the same in this scenario, but because the vertex is on the y-axis, both of these end up being the same. We've talked about this in previous videos. So either this form or that factored form, both of them are the same parabola. It's this parabola right there. Now, what about this parabola over here, if we're going to get an equation for it? So let's start off with the factored form. Notice that we have the origin, so we know that the factor for that is just a single x, and then we have an x-intercept of 30. The factor for that is x minus 30, like that. And then we can solve for this a value by, again, plugging in that vertex. So we plug in 10 for h, and then we plug in 15 for x, and we'd actually end up with the same a value. So we'd end up with 15 times negative 15, which would give us negative 225. Divide both sides by negative 225. We end up with negative 2 over 45. Okay, so this here, we don't even have to put that bracket. It would be negative 2 over 45 x times x minus 30. Okay, so it makes sense that the a value is the same because we're not changing the compression, right? It's the same scenario, it's the same tunnel. We're just taking the parabola and shifting it, right? So the only thing that's going to change is the intercepts. So they're going from this, from negative 15, positive 15, to 0 and 30. That's all that's changing. So it makes sense that the a value is going to stay the same. Now, this is the factored form. If you want to get the standard form, you can just expand it. So this times that would be negative 2 over 45 x squared. And then what is negative 2 over 45 times negative 30? This would be what? 30, 15, like that. So it would be positive 4 over 3. Right? 30 over 45 simplifies to 2 over 3. The negatives turn into a positive. Yeah, so it would just end up being plus 4 over 3x, right? This times the negative 30 would give us positive 4 over 3x. So this is the standard form of this parabola. You could check this on Desmos as well. You could take this parabola, take this parabola. If you graph them, it's going to be the same graph. Now you could also get the vertex form. If we were to do that, we would use the vertex first. So we'd have h equals a x minus 15 squared plus 10, like that. Okay, and then from there we could plug in this point or this point to solve for the a value. Let's plug in the origin. So 0 for h, 0 for x. Bring the 10 over. Again, you'd end up with the same a value. Negative 15 squared is 225. Negative 10 over 225, that simplifies to negative 2 over 45, like that. So we could put this a value here. Okay, so a bunch of different equations you can get. Again, I'm more so focusing on the intercepts because that's what this section is about, but you can get the other equations as well. So all three of these is this parabola. It's the same parabola. Again, you could take that, graph it, test it out yourself, and you would see that they'd be the same parabola. All right, so that's it for part A. Now in part B, what they're asking for is what is the height going to be at a horizontal distance of 3 meters from one end of the tunnel. And so here you got to be careful because the x value you're going to plug in, we're going to use both equations. The x value you're going to plug in for this equation and this equation, they're actually going to be different. So here, okay, this is at negative 15, at an x value, negative 15. So a horizontal distance of 3 meters from one end what's this x value going to be then? It's going to be negative 12. So that's what we would plug in into these equations here to get that corresponding height. That's what we are solving for. You could also plug in positive 12. It could be 3 meters from this end, right? I'm going to stick to, again, it doesn't matter. You could plug in positive 12 or negative 12. It's going to give you that same height, right? Because you're going to end up, if you plug in negative 12, or positive 12, you're going to end up with the same set of brackets that are going to be multiplying. They're just going to be switched around, and negative 2 over 45 is not going to change. And if you plug in negative 12 here or positive 12, well, because we're going to be squaring that, it's going to end up being positive 144. So it doesn't matter which one you plug in, it's just understanding why it's negative 12 or positive 12. 3 meters from one end. And the x value, this x value for these equations represents something different than what that x value represents. So you could take this negative 12 or positive 12, you could plug it into either one of these. I'm going to plug it into, because we're dealing with the intercepts more, let's plug it into the factored form. But again, it should give you the same answer. But if I plug it in here, kind of running out of room here, I'm kind of all over the place with this question, sorry about that. Hopefully you're following along. So let's do the algebra here. So we'd have negative 2 over 45. If we plug in, I'm going to just plug in one of these. Let's just plug in the positive 12. So we'll have 12 plus 15, which is 27. Then we'll have 12 minus 15, which would give us negative 3, like that. Okay, and then negative 3, so the negative cancels out, so that would be positive, so we could put positive. Now 3 goes into 45 15 times, so we'd end up with 2 times 27, which is 54, over 15. And then this, we could divide this by 3, which would give us 18. We could divide this by 3, which would give us 5. Right, so 18, the height ends up being 18 over 5 meters. Okay, and in decimals, that would be 3.6 meters. Okay, so from a horizontal distance of 3 meters from one of the ends, the height of the bridge ends up being 3.6 meters over here. This is not to scale, this should be a little bit lower, but hopefully you see what's happening over here. Okay, so that ends up being the height right there for part B. Now over here, because it's the same bridge, well, 3 meters, a horizontal distance of 3 meters from one of the ends, whether from this end or from this end, we should get the exact same height, right? But notice that the x value is going to be different. In this case, the x value is actually just going to be 3. Or we could plug in an x value of 27, because that would be 3 meters from this end. But I'm going to focus on this end, right? Because 3 is a nicer number to work with versus 27. So 3 meters from one end, we'd plug in 3 for these x values, versus over here, we're plugging in negative 12 or positive 12 for these x values. So hopefully you're seeing the difference in both of these. And so here, let's see what height we end up getting. So again, you could plug in this 3. These are all the same parabolas. You could plug in the 3 for any of these. I'm going to plug it into this one. So what do we get? We get negative 2 over 45 times 3 times 3 minus 30, which is negative 27. And actually notice, I erased it, but this is the exact same thing that we were multiplying right here. We ended up with those same brackets, right? The same values that we're multiplying throughout. We just got to it in a different way, with a different parabola, with a different x value. Okay, so this, when you multiply all of this, again, this is going to end up being 15. and then you'll end up with, again, 54 over 15, which simplifies to 18 over 5, right? So you get that same height, 18 over 5 meters, or 3.6 meters. Okay, so that's how you could use, that's how you create either of the equations, and then how you could use both of the equations to find the same height. You just got to be careful with what you're plugging in for x.